Welcome back, everyone. Welcome back, my dear students. Today we are going to talk about a new lecture that is called the correlation. 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 Correlation is kind of mathematical relationship between two variables. We call them dependent variable and independent variable. Usually, the independent variable affect the dependent variable. As example, the ice cream and the temperature. Temperature and the sales of the ice cream. You can tell me the more it gets hot, the more it gets hot, the more the sales of the ice cream. And the less it gets hot, the less is the sales of the ice cream. We call the temperature, this we call it independent variable. Independent variable. And we call the ice cream dependent variable. So while the temperature is the independent, because the independent affect the temperature is the one who affect the ice cream sales. The independent affect the dependent and not the opposite. The dependent cannot affect, the ice cream cannot change the weather. No. So, but the weather can change the sales of the ice cream. So this is a relationship, this we call it the correlation. We have two kinds of correlation. We have two types of correlation. We have positive correlation. We have two types of correlation. Based on the signal of what we will get the output of this example. So correlation may be positive and may be negative. The positive, when the independent factor increase leads to the dependent to increase. Both of them in the same, like as example, the relationship between the temperature and the sales of ice cream. So when the temperatures go high, when the temperature go high, so it goes high, so the ice cream sales goes high too. And the opposite. So the direction of the arrows are the same. This is, we call it positive relationship. And we have correlation that is negative relationship. Negative means one up and one down. So as example, increase in the price of any product, when the price of any product increase, the quantity demand or the demand decrease. The demand. So if the price goes up, people will buy less. And when the prices go down, then the demand will increase. Demand will go up. The demand will increase. So this kind of relationship, look at the arrows, one up and one down and one up. Here it is negative. But here the arrows are in the same direction, both up together or both down together. So when it's both up together or both down together, we call it positive correlation. But when it's one up and one down, that means it's a negative correlation. This about the correlation, and now we will go to an example here today. I have an example for you about the correlation and how to calculate the correlation. Let's see how I will calculate the correlation. Now let's move forward and see how we will calculate the correlation from this point, from this example. Calculate, but we'll do it according to person correlation, because we have a Spearman for ranks and we have person correlation as well for the amounts. So what we will do here, find the correlation, person correlation based on person, that's fine. What we will do here is, first thing of all, that we will put the variables that he gave me in the example, we will put it vertically. So here we go. So here we have x, and here we have y. I didn't do anything. What came on horizontal, I will put it vertical. So I have x with the values of 2. Let's see the values of x. We have 2. We have 3, 4, 5, 6. 3, 4, 5, 6. And we have the values of y, which is 2, 3, 6, 7, 7. 2, 3, 6, 7, 7. Perfect, cool. Then what we will do now, we will start to get a new column that we call it xy. So xy is what? Simply we'll multiply x by y. 2 by 2 will give me 4. 3 times 3 will give me 9. 4, 6, 24. 5 by 7, 35. 6 by 7, 42. And the sum of this xy will be 1, 1, 4. How about the sum? How about the sum of x? The sum of x is 20, 20. Let's see. 2 and 3, 5 and 4, 9, 9, 5, 13, 14 and 6, 20. And the sum of y is 25. 25. Because when you see 2 and 3, 5 and 6, 11, 11 and 7, 18, 18 and 7, 25. Now, we will get another column. So the first column we did today is xy. Then we will do another column which is called x squared. Simply, I will multiply x squared. 2 by 2 will give me 4. 3 by 3 will give me 9. 4 by 4 will give me 16. 5 times 5 will give me 25. I will multiply it by its own self. So 5 by 5, 4 by 4, 3 by 3, 2 by 2. 6 by 6 will give me 36. And the sum of this column will give me, x squared will give me 90, 90, 90. Okay, here are the sums. Here are the sums, because I need the sums after this. Okay, will give me 90. Then same thing we will do for x squared, we'll do for y squared as well. We'll do for y squared as well. So what we did for x, we will do for y. Perfect. Perfect. Y, the same thing, the same issue. And this is the last column we will do today. We are not going to do any columns. So y is here. 2 by 2 will give me 4. 3 by 3 will give me 9. 6 by 6 will give me 36. 7 by 7 will give me 49. 7 by 7 will give me again 49. When I sum all this together, 4 and 9, 13, plus 36, plus 49, plus 49, this will give me 147. 147. So this will be 147. Okay, I have the submission now already. I have all of them. Then I will apply the formula to get the Pearson's correlation. So the formula will be like that way. I will get the formula by that way. R, or the correlation, R of the correlation. Here we go. Or correlation, C-O-R-R-E-L-A-T-I-O-N. R correlation will equals summation xy minus summation x, sum x, sum y, divided by n. And n is the number of the observations. Summation xy is here, 114. Summation x, summation y. Summation x is 20. Summation y is 25. Divided by n. N are number of the observations. How many observations I have here, or how many experiments? 1, 2, 3, 4, 5. This is not, because this is the sum. So 1, 2, 3, 4, 5 I have. So n will be 5. N will be 5. Then divided by, here we go, the root square of what? Summation x squared minus summation x all square, summation x all square, summation x all square divided by n, all this in one bracket. Then the second bracket is the same thing for y. Summation y square minus summation y all square divided by n. And now close the root. So here it goes. Summation x square minus summation x all square divided by n times summation y square minus summation y all square divided by n. Note that the square is up here. The square is up. The n is not included in the square. The n is not included in the square. Then I will substitute in the formula now. I will substitute in my formula. Summation xy, how much it is xy? 114. 114. I am now in the nomination, in the upper part. This is the upper part, the nomination, and this is the lower part. I think if it's okay, yeah, it's okay. I just wanted to make it. So this is the upper part, this is the nomination, and this is after the this line is the denomination. Okay. Summation xy is 114 minus summation x is 20 by summation y is 25 divided by n. N is the number. N is the number of observations. We said 1, 2, 3, 4, 5. N equals 5, the number of observations. So number of observations is 5. And here we go. This is the, I will work now on the down part or the denomination. The root square of summation x square. X square is 90 minus x square, like you see here, x square is 90 minus summation x all square, summation x all square. X is 20 all square, the 20 square, square of 20, or power 2, divided by 5. We said the n is not in the square. The square is for the x only, but not for the n. The n is out of the square. Then again, the same thing for y. Summation y square is 25. Summation y square is 147 minus summation y all square 25 all square divided by 5. And I will close the brackets. The same thing I did here for the x, I will do for the y. So I will complete the example here in this part, please. I will complete it here because the board is done here. I apologize for this. So 114 minus this amount, when you finish it 20 by times 25 by 5, it will give you 100. So finish it by the calculator to give you 100. Okay. Divided by the root square of the first amount would be, when you finish the first amount, this is 20 by 20, this is 400 by 5, this is 80 will be 80, 90 minus 80 will give me 10. So the first part is 10. The second part is 140. This is 25 by 25 divided by 5. So 100 is 625 by 5. This will give me 125. So it is like 147 minus 125. So this will equals 22. So we are talking now about the amount in the here will be up 114 minus 100, 114 minus 100. This will be 14 divided by the root square of 220. Why 220? Because 10 times 22 will give me 220. Perfect. Last point is I will get, then this will equal 14 divided by the root square of 220 is 14.8. So it will equal 14 by 14.8. 14.8. It will equal 14 by 14.8. The root square of 220 is 14.8. So this will be like this, point or 0.94. When you do it with the calculator, 14 divided by 14.8, this will give you 0.94, which means it is a very strong correlation because it's more than 5%. It's positive correlation, it's a positive, and strong correlation, strong. Strong, why? Because it is more than 0.5. Because it is more than 0.5. Because with this correlation itself, as long as correlation is less than 0.5, this is weak correlation. But more than 0.5, because 0.94 is more than 0.95. 0.5, more than 0.5. As long as the correlation is more than 50%, as long as the correlation is more than 50%, then this we call it a strong correlation. Strong correlation. So this was Pearson's method of correlation. This was methods, and I said I will say again quickly what we did here before I finish. Pearson's method of correlation, or Carl Pearson. His name is Carl Pearson. Pearson, sorry, I did it. Actually, it is PEA. The name I missed one P-E-A-R-S-O-N, Pearson, like Pearson Airport. So Pearson correlation, and here it is as well, Pearson correlation. So Pearson, his name is Carl Pearson, and let us go back to what he said quickly. We'll do that quickly back. We have X and Y. We put them horizontal, we put them vertical. Then we multiply X times Y to give the column of XY. We squared X power 2, and we squared Y power 2. So like this as example, now XY 2 by 2 is 4, 3 by 3, 9, and so on. X squared 2 times 2 is 4, 3 times 3 is 9, 4 times multiplied by itself. Square means multiply by itself. And Y squared, same thing, 2 times 2 is 4, 3 times 3 is 9, and so on. Then we add them all together, 147. The add of this is 90. Add them up. 4 and 9 is 114. 2 and 3 and 6, 25. And for X is 20. Then we apply the Carl Pearson correlation. We said that it will equals, this is the whole formula. This is the whole formula, like this. This is the whole formula. In green here, you can see it now. This is the whole formula. And it consists of summation xy minus summation x summation y divided by n, divided down the root. This is root square. Down the root square, summation x squared minus summation x all squared divided by n, and the same for y. So we finish it, and at the end, it is 0.94, which means a strong correlation, because we said the correlation might be is a strong correlation if it is more than 0.5 or 50%. This is more than 50%, then it's a strong correlation. Shall see you next on the next lecture. Thank you so much, and enjoy the rest of the day. All of you have a very good night. Bye-bye, everyone.